Hydrogen engines, also known as hydrogen internal combustion engines (HICE), are a type of engine that uses hydrogen as its primary fuel source. These engines operate similarly to traditional internal combustion engines (ICE), but instead of using gasoline or diesel, they utilize hydrogen gas. A hydrogen vehicle is a vehicle that uses hydrogen fuel for motive power. Hydrogen vehicles include hydrogen-fueled space rockets, as well as ships and aircraft. Power is generated by converting the chemical energy of hydrogen to mechanical energy, either by reacting hydrogen with oxygen in a fuel cell to power electric motors, or, less commonly, by burning hydrogen in an internal combustion engine. The 2015 Toyota Mirai is the world's first mass-produced and commercially marketed dedicated hydrogen fuel cell vehicles that is not a modification of an existing model. The Mirai is based on the Toyota Fuel Cell Vehicle (FCV) concept car shown. As of 2021, there are 2 models of hydrogen cars publicly available in select markets. The Toyota Mirai 2014, which is the world's first mass-produced dedicated fuel cell electric vehicle (FCEV), and the Hyundai Nexo 2018 There are also fuel cell buses. Hydrogen aircraft are not expected to carry many passengers long-haul before the 2030s at the earliest. As of 2019, 98% of hydrogen is produced by steam methane reforming, which emits carbon dioxide. It can be produced by electrolysis of water or by thermochemical or pyrolytic means using renewable feedstocks, but the processes are currently expensive. Various technologies are being developed that aim to deliver costs low enough and quantities great enough to compete with hydrogen production using natural gas. Vehicles running on hydrogen technology benefit from a long range on a single refueling, but are subject to several drawbacks. High carbon emissions when hydrogen is produced from natural gas, capital cost burden, low energy content per unit volume at ambient conditions, production and compression of hydrogen, the investment required to build refueling infrastructure around the world to dispense hydrogen, and transportation of hydrogen. Automobiles, buses, forklifts, trains, canal boats, ships, aeroplanes, submarines, and rockets can run on hydrogen in various forms. NASA used hydrogen to launch space shuttles into space. A working toy model car runs on solar power, using a regenerative fuel cell to store energy in the form of hydrogen and oxygen gas. It can then convert the fuel back into water to release the solar energy. Aeroplanes, hydrogen planes. The Boeing fuel cell demonstrator, powered by hydrogen fuel cell companies such as Boeing, Lange Aviation, and the German Aerospace Center, pursue hydrogen as fuel for crewed and uncrewed aeroplanes. In February 2008, Boeing tested a crewed flight of a small aircraft powered by a hydrogen fuel cell. Uncrewed hydrogen planes have also been tested. For large passenger aeroplanes, The Times reported that Boeing said that hydrogen fuel cells were unlikely to power the engines of large passenger jet aeroplanes, but could be used as backup or auxiliary power units on board. In July 2010, Boeing unveiled its hydrogen-powered Phantom IUV, powered by 2 Ford internal combustion engines that have been converted to run on hydrogen. In Britain, the reaction engine A2 has been proposed to use the thermodynamic properties of liquid hydrogen to achieve very high speed, long distance, antipodal flight by burning it in a pre-cooled jet engine. Automobiles edit. As of 2021, there are 2 hydrogen cars publicly available in select markets: the Toyota Mirai and the Hyundai Nexo. The Honda Clarity was produced from 2016 to 2021. The first road vehicle powered by a hydrogen fuel cell was the Chevrolet Electrovan, introduced by General Motors in 1966. The Toyota FCHV and Honda FCX, which began leasing on December 2, 2002, became the world's first government-certified commercial hydrogen fuel cell vehicles, and the Honda FCX Clarity, which began leasing in 2008, was the world's first hydrogen fuel cell vehicle designed for mass production, rather than adapting an existing model. Honda established the world's first fuel cell vehicle dealer network in 2008, and at the time was the only company able to lease hydrogen fuel cell vehicles to private customers. The Hyundai Nexo is a hydrogen fuel cell-powered crossover SUV. The 2013 Hyundai Tucson FCEV, a modified Tucson, was introduced to the market as a lease-only vehicle, and Hyundai Motors claimed it was the world's first mass-produced hydrogen fuel cell vehicle. However, due to high prices and a lack of charging infrastructure, sales fell far short of initial plans, with only 273 units sold by the end of May 2015. Hyundai Nexo, which succeeded the Tucson in 2018, was selected as the safest SUV by the Euro NCAP in 2018. Toyota launched the world's first dedicated mass-produced fuel cell vehicle, FCV, the Mirai, in Japan at the end of 2014, and began sales in California, mainly the Los Angeles area, and also in selected markets in Europe, the UK, Germany and Denmark, later in 2015. The car has a range of 312 mi, 502 kilometers, and takes about 5 minutes to refill its hydrogen tank. The initial sale price in Japan was about 7 million yen, $69,000. Former European Parliament President Pat Cox estimated that Toyota would initially lose about $100,000 on each Mirai sold. 36 At the end of 2019, Toyota had sold over 10,000 Mirais. Many automobile companies have introduced demonstration models in limited numbers, see list of fuel cell vehicles and list of hydrogen internal combustion engine vehicles. In 2013, BMW leased hydrogen technology from Toyota, and a group formed by Ford Motor Company, Daimler AG and Nissan announced a collaboration on hydrogen technology development. In 2015, Toyota announced that it would offer all 5,680 patents related to hydrogen fuel cell vehicles and hydrogen fuel cell charging station technology, which it has been researching for over 20 years, to its competitors free of charge, in order to stimulate the market for hydrogen-powered vehicles. By 2017, however, Daimler had abandoned hydrogen vehicle development, and most of the automobile companies developing hydrogen cars had switched their focus to battery electric vehicles. By 2020, all but 3 automobile companies had abandoned plans to manufacture hydrogen cars. Auto Racing, a record of 207.297 miles per hour, 333.612 kilometers per hour, was set by a prototype Ford Fusion Hydrogen 999 fuel cell race car at the Bondel Salt Flats in August 2007, using a large compressed oxygen tank to increase power. The land speed record for a hydrogen-powered vehicle of 286.476 miles per hour, 461.038 kilometers per hour, was set by Ohio State University's Buckeye Bolt 2, which achieved a flying mile speed of 280.007 miles per hour, 450.628 kilometers per hour, at the Bondel Salt Flats in August 2008. In 2007, the Hydrogen Electric Racing Federation was formed as a racing organization for hydrogen fuel cell-powered vehicles. The organization sponsored the Hydrogen 500, a 500-mile race. Buses fuel cell bus A Solaris Urbino 12 bus near its factory in Bolesław, Poland. Fuel cell buses have been trialed by several manufacturers in different locations, for example, the Ursus Lublin. Solaris Bus and Coach introduced its Urbino 12 hydrogen electric buses in 2019. Several dozen were ordered. In 2022, the city of Montpellier, France, cancelled a contract to procure 51 buses powered by hydrogen fuel cells when it found that the cost of operation for hydrogen buses is 6 times the cost of electricity. Trams and trains. China rolls out its first hydrogen fuel cell hybrid locomotive, Xinhua, 28 January 2021. In March 2015, China South Rail Corporation, CSR, demonstrated the world's first hydrogen fuel cell powered tramcar at an assembly facility in Qingdao. Tracks for the new vehicle have been built in 7 Chinese cities. In northern Germany in 2018, the first fuel cell-powered Canary Island trains were placed into service. Excess power is stored in lithium-ion batteries. Ships hydrogen-powered shippers of 2019 hydrogen fuel cells are not suitable for propulsion in large long-distance ships, but they are being considered as a range extender for smaller short-distance, low-speed electric vessels, such as ferries. Hydrogen in ammonia is being considered as a long-distance fuel. Bicycles. PHB Hydrogen Bicyclane 2007, Pearl Hydrogen Power Source Technology Company of Shanghai, China, demonstrated a PHB hydrogen bicycle. In 2014, Australian scientists from the University of New South Wales presented their high-cycle model. The same year, Canyon Bicycles started to work on the EcoSpeed concept bicycle. In 2017, Pragma Industries of France developed a bicycle that was able to travel 100 kilometers on a single hydrogen cylinder. In 2019, Pragma announced that the product, Alpha Bike, has been improved to offer an electrically assisted pedaling range of 150 kilometers, and the first 200 of the bikes are to be provided to journalists covering the 45th G7 summit in Biarritz, France. Lloyd Alder of Treehugger responded to the announcement, asking why go through the trouble of using electricity to make hydrogen, only to turn it back into electricity to charge a battery to run the e-bike or pick, a fuel that needs an expensive filling station that can only handle 35 bikes a day, when you can charge a battery-powered bike anywhere. If you were a captive fleet operator, why not just swap out batteries to get the range and the fast turnover? Military Vehicles. General Motors Military Division, GM Defense, focuses on hydrogen fuel cell vehicles. Its Cirrus, Silent Utility Rover Universal Superstructure, is a flexible fuel cell electric platform with autonomous capabilities. Since April 2017, the U.S. Army has been testing the commercial Chevrolet Colorado ZH2 on its U.S. bases to determine the viability of hydrogen-powered vehicles in military mission tactical environments. Motorcycles and scooters. And develops electric motorcycles powered by a hydrogen fuel cell, including the Crossage and Biplane. Other manufacturers as Vectrix are working on hydrogen scooters. 64 Finally, hydrogen fuel cell electric hybrid scooters are being made, such as the Suzuki Bergman Fuel Cell SCOOTER65 and the Fibrid. The Bergman received whole vehicle type approval in the EU. The Taiwanese company APFCT conducted a live street test with 80 fuel cell scooters for Taiwan's Bureau of Energy. Auto rickshaws. Hydrogen auto rickshaw concept vehicles have been built by Mahindra Hi Alpha and Bajaj Auto. Quads and tractors. Autostudi SRL's H2 is a hydrogen-powered quad capable of transporting 1 to 3 passengers. A concept for a hydrogen-powered tractor has been proposed. Fork trucks. A hydrogen internal combustion engine, or HICE, forklift or HICE lift truck is a hydrogen-fueled, internal combustion engine-powered industrial forklift truck used for lifting and transporting materials. The first production HICE forklift truck based on the Linde X39 diesel was presented at an exposition in Hanover on May 27, 2008. It used a 2.0-liter, 43 kilowatts, 58 horsepower diesel internal combustion engine, converted to use hydrogen as a fuel with the use of a compressor and direct injection. In 2013, there were over 4,000 fuel cell forklifts used in material handling in the US. The global market was estimated at 1 million fuel cell-powered forklifts per year for 2014-2016. Fleets are being operated by companies around the world. Pike Research stated in 2011 that fuel cell-powered forklifts will be the largest driver of hydrogen fuel demand by 2020. Most companies in Europe and the US do not use petroleum-powered forklifts, as these vehicles work indoors, where emissions must be controlled, and instead use electric forklifts. Fuel cell-powered forklifts can provide benefits over battery-powered forklifts, as they can be refueled in 3 minutes. They can be used in refrigerated warehouses, as their performance is not degraded by lower temperatures. The fuel cell units are often designed as drop-in replacements. Rocket's Centaur rocket stage was the first to use liquid hydrogen. Many large rockets use liquid hydrogen as fuel, with liquid oxygen as an oxidizer, LH2/LOX. An advantage of hydrogen rocket fuel is the high effective exhaust velocity compared to kerosene/LOX or UDMH/NTO engines. According to the Tsiolkovsky rocket equation, a rocket with higher exhaust velocity uses less propellant to accelerate. Also, the energy density of hydrogen is greater than any other fuel. 83 LH2/LOX also yields the greatest efficiency in relation to the amount of propellant consumed of any known rocket propellant. A disadvantage of LH2/LOX engines is the low density and low temperature of liquid hydrogen, which means bigger and insulated, and thus heavier fuel tanks are needed. This increases the rocket's structural mass, which reduces its delta V significantly. Another disadvantage is the poor storability of LH2/LOX powered rockets. Due to the constant hydrogen boil-off, the rocket must be fueled shortly before launch, which makes cryogenic engines unsuitable for ICBMs and other rocket applications, with the need for short launch preparations. Overall, the delta V of a hydrogen stage is typically not much different from that of a dense fueled stage, but the weight of a hydrogen stage is much less, which makes it particularly effective for upper stages, since they are carried by the lower stages. For first stages, dense fueled rockets in studies may show a small advantage due to the smaller vehicle size and lower air drag. LH2/LOX were also used in the Space Shuttle to run the fuel cells that power the electrical systems. The byproduct of the fuel cell is water, which is used for drinking and other applications that require water in space. Heavy Trucks United Parcel Service began testing of a hydrogen-powered delivery vehicle in 2017. In 2020, Hyundai began commercial production of its assigned fuel cell trucks and shipped 10 of them to Switzerland. In 2022 in Australia, 5 hydrogen fuel cell Class 8 trucks were placed into use to transport zinc from Sun Metals' Townsville mine to the port of Townsville, Queensland, to be shipped around the world. Here are some key points about hydrogen engines: fuel combustion. Hydrogen engines combust hydrogen fuel with oxygen from the air, generating mechanical power. The combustion process typically produces water vapor as the only byproduct, making hydrogen engines potentially cleaner in terms of emissions compared to traditional combustion engines. Operation: hydrogen engines function by mixing hydrogen gas with air in the engine's combustion chamber. The mixture is ignited, leading to combustion and the expansion of gases, which in turn drives the engine's pistons and creates mechanical energy. Fueling infrastructure: hydrogen engines require a dedicated hydrogen fueling infrastructure to supply the hydrogen fuel. This infrastructure is currently less widespread compared to gasoline or diesel fueling stations, limiting the widespread adoption of hydrogen engines. Advantages: hydrogen engines have several potential advantages. Hydrogen is a high-energy fuel that can be produced from diverse sources, including renewable energy, making it a potentially sustainable option. Hydrogen engines can also offer low emissions if the hydrogen is produced using renewable energy sources. Challenges: there are also challenges associated with hydrogen engines. One significant challenge is the production, storage, and transportation of hydrogen fuel. Hydrogen is a relatively low-density gas and requires compression or liquefaction for practical storage and transportation, which adds complexity and cost to the infrastructure. Additionally, hydrogen engines may require modifications compared to traditional combustion engines due to the different properties of hydrogen as a fuel. It's worth noting that technology and research in the field of hydrogen engines are continuously evolving.